Hello everyone, my name is Konstantin. I'm going to give you a short overview on this desalination plant and its key features. This is a facility which is used for cleaning and distilling of salt water based on the principles of cavitation, and this is a working prototype. So here's how it works. Salt water is directed from the container to this preheating tank, which is used for heating of water to the temperature of between 40 to 60 degrees Celsius. On the top of the tank we have here the fill sensor. As soon as the temperature rises up to 60 degrees, the sensor actuates the water circulation pump. This is a fully closed circulation system. So what happens after that? The preheated salt water is reaching cavitators or cavitation modules. We have two of them here, number 1 and number 2. In cavitation module, an amazing process is happening. The water is undergoing a cavitation, a physical process whereby pressure variations in a short period of time, water explodes into small cavities and temperature is immediately rising up to 120 degrees Celsius. The water is being evaporated inside the evaporation chamber and is released through outlet manifold to the condensers for cooling. As we have two cavitators, we have here two condensers, number 1 and number 2, and in this way we receive distilled water. Then here we have a filtration tank which is used for brine drainage. The brine, a very much concentrated salt solution, is drained into the tank for further storage. Here we have measuring unit and water inlet valve to control the amount of salt water. Again, this is the closed circulating system which is working pressure of 2–2.5 bars. Salt water is circulating through the system at a speed between 15 to 20 meters per second, which in its turn prevents scale builds up inside condensers. This is one of the main advantages of this system. There is no need to clean the system very often, just one time per year. So, there is a general overview of how this facility works. The system has a number of features, and here's a short insight into key advantages. Due to the specific area of evaporation surface, the chambers provide more efficient evaporation and produce more steam volume as compared to the traditional evaporation systems, between 5 to 7 times more productive and efficient. Second, high pressure. The working pressure is between 2–2.5 bars, which combined with a high circulation speed triggers the cavitation. Third, high speed of salt water circulation inside the system, about 15 to 20 meters per second, which means there is no issue of scale builds up, so you don't need to clean the condensers very often, just one time per year, no more. And the last key advantage is reduced energy consumption as compared to the traditional evaporation systems. So, there was a short presentation of how this system works. It's very simple, very reliable, and industrially scalable, and very perspective. This system can be configured to the customer's needs and has a number of key advantages and features.
The significant advantage of supercavitation method of desalination compared to traditional methods lies in the fact that in the process of cavitation, the water is overheated to the temperature of 120 degrees of Celsius. Because of high temperature, the relative evaporation rate is increased in several times from the area of 1 square meter of evaporation surface, while in the conventional evaporation methods, temperature lies between 40–60 degrees Celsius compared to 100–120 degrees of Celsius in the supercavitation process. Another advantage of this facility is that it can be used in the oil industry by changing and adapting its components, in particular for tar oxidation to produce bitumen, wastewater treatment, for gasoline compounding, and in other fields of oil industry.